Now it's finally time for us to talk about functions in Haskell. Haskell is a functional language, so it's full of functions. If we want to write a function with one argument, x, and the body e, we write it \x arrow e. This is intentionally very reminiscent of what you can write in the lambda calculus, where you write lambda x dot e. So this is what you could write in the lambda calculus, and this was what you'd write in Haskell. Tiny example would be the function that adds 7 to its argument, so that's \x arrow x plus 7. Very often when you declare values that are functions, you do not write them using the anonymous function notation. You could write that your function f is x to x plus 7, but you could also write that f of x is x plus 7. You could always expand this notation to get that if you want. Note that functions always have exactly one argument in Haskell. If we want to write functions that have more than one argument, we can do that using Curried Form. The Curried Form is named after Haskell B. Curry. So it's got nothing to do with Indian cuisine. It's named after Haskell B. Curry, who also is the person after whom the programming language Haskell is named. A tiny example would be that you could write the multiplication function, multiply, and it takes two arguments, x and y. You write multiply x, y, x times y, and this is really short for writing that. Multiply is /x to y to x times y. So this is a function whose body is a function. So that's what this is really short for. This is a higher order function, and it's a higher order function because the body of this function is itself a function. So if we apply multiply to one argument, we would get a function back, and we can do that, of course. We can also write functions in uncurried form. A function of this form also has one argument, but the argument is then of a tuple type. We could write the multiply function slightly differently. Let's call it multiply prime. Multiply prime of the tuple xy is x times y. So what's the type of functions? How do we find the type of a function? And how do we determine the type of an expression that contains functions? There are two type rules for that. The type rules for function abstractions, namely functions of the form \x to e, says that the type of this is an arrow type, t1 to t2. We're typing this in a type environment E. How can we find that this is actually the type of this function? Well, in order to conclude that, we must then extend our type environment with the assumption that the type of the formal parameter is t1, and if we can then conclude using that the body E has type t2, then we can conclude that the function has type t1 to type t2. So this is the rule for for abstraction. Now, what about expressions that contain a function call? So that this would be an expression of the form E1, E2, where E2 would be a function and E2 would be its argument, its actual parameter. How can you type that? Well, assume we have a type environment E and we want to type that. Well, in order to type that, first we must check that E1 is actually a function. So we must check that E1 has a function type, so its type is T1 arrow T2. And then that means that E1 is a function that takes a value of type T1 and returns a value of type T2. So in order for this to type check, we must check that E1 has type T1. So that's the other premise of the type rule, that E2 must have type T1. If that's the case, everything works out fine. And this is the rule for function application. We'll call it app.